Hi everyone. Today we're going to study ratio tests. Let summation of A sub n be a series with positive terms. And suppose that the limit as n approaches infinity of the absolute value of this fraction. In the numerator, this is A sub n plus 1. In the denominator is A sub n. And this value will be equal to rho. Then this is the ratio test. The series converges if the rho is less than 1. The series diverges if rho is greater than 1. And C, the test fails if rho is equal to 1. Let's see example 1. Check the convergence of the series using ratio tests. Summation from n equals 0 up to infinity of 5 raised to n all over n factorial. Our a sub n is equal to this 5 raised to n all over n factorial. Next is the a sub n plus 1. It means for every n we see in here, we're going to change by n plus 1. So this fraction is now 5 raised to n plus 1 in the numerator all over the quantity n plus 1 factorial in the denominator. By ratio test, this is our limit formula. The limit as n approaches infinity of the absolute value of a sub n plus 1 all over a sub n. For our simple step, we will first evaluate the fraction. So we copy it here. Then we substitute the corresponding values. The a sub n plus 1 is now here in the numerator over the a sub n. This is the value in the denominator. We can see here a complex fraction. So let us simplify this into the a sub n plus 1 we copy here multiplied by the reciprocal of a sub n. So this is now n factorial on top all over 5 raised to n. Simplifying further, look at the first fraction, specifically in the numerator. This 5 raised to n plus 1 can be rewritten as 5 raised to n times 5. While in the denominator, this quantity n plus 1 factorial is equal to n factorial times the n plus 1, multiplied by the second fraction, which we will just copy down here. We can see that we can cancel some terms. First, the 5 raised to n, we cancel here and in here. Also, the n factorial, we cancel both n factorials. Simplifying the product, we will have now 5 all over the quantity n plus 1. This is now the value that we can substitute in our fraction in here. So it becomes the limit as n approaches infinity of the absolute value of the fraction 5 over n plus 1. Let us now evaluate the limit, and it will be like this. The absolute value of the fraction 5 all over infinity plus 1. In the denominator, this infinity plus 1 will grow bigger and bigger. So the constant 5 divided by a bigger number will come to the value 0. Now let's come to the ratio tests, and this is our rule. Now, since 0 is less than 1, we say that the series converges. Example 2. Check the convergence of the series using ratio test. We have summation from n equals 0 up to infinity of 7 raised to n all over n squared. We write first the a sub n. This is the 7 raised to n all over n squared, followed by the a sub n plus 1. We change all n by n plus 1. So we have now 7 raised to n plus 1 all over the square of n plus 1. Now the ratio test rule is here. First, let us simplify the fraction. We copy it on the side. Let us substitute now the corresponding values. The a sub n plus 1 is here, divided by the a sub n, which is now here. Simplifying our complex fraction, we have now this value a sub n plus 1 multiplied by the reciprocal of a sub n. It's now here. Simplifying our first fraction, the 7 raised to n plus 1 can be written as 7 raised to n times 7. Then we will just copy the rest of the terms. And from here, we can see that we can cancel the 7 raised to n. Simplifying now the product, we have 7 times n squared all over the square of n plus 1. We can simplify this further by writing 7 times the quantity n over n plus 1. The fraction is raised to power 2. This is now the value that we're going to substitute in the ratio test formula. So the limit as n approaches infinity is now the absolute value of 7 times n over n plus 1, and this is raised to 2. By the rule of limits at infinity, our denominator here can be written like this, which means we factor out that n, and what remains here is 1 plus this number 1 becomes 1 over n. We can see that we can cancel the n and the n. Simplifying further, the limit value now becomes like this. The fraction becomes 1 all over 1 plus 1 over n, and the power 2 is there. Now let us evaluate the limit, which means we're going to substitute this infinity to this value n. So we have here 1 over infinity, which we know it will become 0. So simplifying now, 1 over 1 is simply 1. 1 squared is 1. And 7 multiplied by 1 is simply 7. Here is now the rule again for the ratio tests. We can see that the value is 7 and this is more than 1, which means the series diverges. I hope you learned something from this video. See you again next time.